Welcome to video 11 in my rotational motion playlist. Conceptual questions. Do you really understand rotational physics? In this video, I have 7 great conceptual questions. There's no math here. Sometimes these are more challenging than solving the problems. Question 1. Why is it important to balance car tires? Use principles of rotational motion to explain your answer. Also, describe the difference between static and dynamic tire balancing. Are you ready for the answer? A tire is unbalanced when the mass is not evenly distributed about its center. This is an example of an unbalanced tire. There's more mass on this side than there is on the symmetric side. You'd have to add mass on this side to balance the tire and make it so the mass is symmetrically distributed about the center. Tires become unbalanced from road damage, potholes, flat spots on the tire from hard braking or skidding. This is why your tire becomes unbalanced over time. If mass isn't evenly distributed, the center of mass won't align with the rotation axis. As the wheel spins, the center of mass orbits the axis. This creates a centripetal force that constantly tugs on the axle. This causes vibrations, noise, and uneven tire wear. If you don't repair it, it leads to long-term damage of the axle and suspension. When the wheel is unbalanced, the center of mass rotates about the axle, causing a constant tugging on the axle. Static balance corrects vertical imbalance. It removes up and down vibrations. So imagine this wheel has more mass on the top than it does on the bottom. Static balance would add a countermass on the bottom of the wheel. Dynamic balance takes into account this mass difference as well as the mass difference across the wheel. Question 2. A uniform solid cylinder can rotate about the X, Y, or Z axis, all of which pass through the center of mass. Rank these 3 axes in order of moment of inertia from greatest to least, and explain your reasoning based on the cylinder's geometry. This uniform solid cylinder can be rotated about the y-axis, it can be rotated about the x-axis, and it can be rotated about the z-axis. You would need a dot on the edge to be able to visualize this better. The moment of inertia about the x-axis and the y-axis are equal because the mass is distributed symmetrically with respect to both axes. On contrast, the moment of inertia about the z-axis is smaller since the mass is on average located closer to the axis of rotation. Question 3. Why doesn't the Tower of Pisa topple over? And here's the answer. When the center of mass is above the base, gravitational torque is balanced by structural forces such as deep anchoring or counterweights. So there's no net torque and the building remains stable. The tower is leaning and the center of mass is shifted slightly to the right. It's still above the base of the building. However, if the center of mass moves outside the base, the gravitational torque creates an unbalanced moment that exceeds what the structure can resist, making it unstable and it would tip over. For example, if the building was leaning even more, such that this was the center of mass, now this is no longer over the base, and the building would have a much harder time remaining stable. Question 4. Can a small force ever produce a greater torque than a large force? Explain. The answer is yes. Torque depends on both the force and the distance from the axis of rotation. A small force applied far from the axis can produce more torque than a large force applied close to the axis. For example, the woman in this image is using a lever to lift an object much heavier than she could with just her bare hands. This demonstrates mechanical advantage, a principle that has been used in technology for hundreds of years and continues to play a key role in many modern tools, including bicycle wheels, crowbars, wheelbarrows, scissors, bottle openers, and screwdrivers. Question number 5. On a bicycle with multiple gears, when is it harder to pedal? When using a small rear sprocket or a large rear sprocket? Here's the bike chain, this is the front sprocket and the rear sprocket. In this image, the radius of the rear sprocket is smaller than the radius of the front sprocket. The answer is it's harder to pedal with a large gear ratio. The gear ratio is equal to the radius of the front sprocket divided by the radius of the rear sprocket. A small rear sprocket increases the gear ratio, causing the rear wheel to spin more for each turn of the pedal. This results in higher speed but less torque at the wheel, making pedaling more difficult. It's a trade-off between force and speed. Question 6. A sphere and a cylinder of equal mass and radius roll down a ramp. Which reaches the bottom first and why? Let's begin with a demonstration of a similar setup to help visualize this.
All of the cylinders have the same mass, but they differ in the way that mass is distributed. This first one has most of its mass concentrated near the center in this copper cylinder that is mounted there. This one is of uniform density, and it has its mass equally distributed throughout. And this one has its mass concentrated very near the rim.
The solid sphere reaches the bottom first because it has a smaller moment of inertia. The moment of inertia of a solid sphere is 2/5 mr squared, and the moment of inertia of a cylinder is 1/2 mr squared. more of the sphere's potential energy becomes translational kinetic energy. They both start with the same potential energy, and in both cases, it's entirely converted into kinetic energy. The kinetic energy is split between translational kinetic energy of the center of mass and rotational kinetic energy about the center of mass. The sphere transforms more of the potential energy into translational kinetic energy than the cylinder does. And finally, question number 7. When pulling tape from a reel, is the tape more likely to break when the reel is full or nearly empty? Explain why. The tape is more likely to break when the reel is full. A full reel has a much higher moment of inertia, which means it resists changes in rotation. To accelerate or jerk the tape from a full reel, more tension is required, increasing the chance of the tape snapping. When the reel is nearly empty, the inertia is lower and less tension is needed.
AcePhysics.org. Math and Physics Tutoring with Dr. H. AcePhysics.org. Math and Physics Tutoring with Dr. Hudis.